Greetings to you. Welcome to Physics with Ben. In today's video, I want us to run an experiment in current electricity. Don't forget to subscribe and share this video to those that need it. You click in the description box below and you'll get a full theory of this experiment. A theory on Wheatstone bridge, meter bridge, and potentiometer. All of them in the description box. So without wasting much time, let's go straight to the point. This is question we are dealing with June 1988 SSCE Physics 1 practicals. This is alternative A. So let's begin. You may screenshot. I will be pointing my hand as I read with you. So let's go. Connect up the circuit as shown here. PQ is the potentiometer wire. Record the ammeter reading I0 and the voltmeter reading V0 when the jockey is not in contact with the potentiometer wire PQ. Then place the jockey to make contact with the PQ at J such that PJ is equal to 40 cm. Read and record I and V. Repeat the experiment with PJ equals to 50, 60, 70, and 80 cm. In each case, read and record the values of I and V. Tabulate your readings. Plot a graph with I on the vertical axis and V on the horizontal axis, starting both axes from the origin. Determine the slope of the graph and the value of V when I is equal to 0. State 2 precautions you took to ensure accurate results. That is 24 marks. BI. Given that E is equal to V plus IR in the experiments above, use your graph to determine the value of R. BII. What did the voltmeter measure when the jockey made contact with the potentiometer wire at J? B. What would be wrong with the connections if the ammeter deflected in the opposite direction during the experiment? 2 marks. State 2 advantages of using a potentiometer over a voltmeter for measuring potential difference. 2 marks. So, let us begin. The circuit diagram here is not too obvious, so I have drawn it down here as you can see on the book, and I'm going to teach you how to connect the circuit diagram correctly, and then we'll run the experiment. And another thing I would like us to do is quickly I would like us to generate the table of values. The table of values is something very, very important in every physics experiment. And so I would like us to generate the table of values. The table of values carries the highest marks. Now, follow me as I will teach you how to generate table of values if you don't know how to do it. If you observe very well, they ask you to read the ammeter reading, underline this word, this I0, underline V0. These are constants in the experiment. You are supposed to record this on top of your table of values or observations. And you are going to record this to 2 decimal places. Take notes. So while drawing our table of values, we are going to include I0 and V0 on top of the table of values. When the jockey is not in contact with the potentiometer, PQ, then place the jockey to make contact with PQ at j such that pj. Now, pj is another parameter in the table of value. You're going to record pj in the composite table, all of the values in cm. So one value of pj is this. If you come down, other values of pj are 50, 60, 70, and 80 cm. In each case, read and record the values of I. Every parameter I'm underlining here are the stuff you will need in your table of values. So, your table of values will have pj, I, and v as your composite parameters, while I0 and V0 will be on top of the table. So let's begin. So if you have your Waec graph sheets, you can start. So this is what I mean. The first things first is just write table of values. Right on top of the book, table of values. Table of values or observations. So I said that I0 will be recorded to 2 cm. We also have our V0 all on top of the table of values. Now, write serial number. Draw a straight line. Serial number simply means the number of times you are going to perform the experiments. Very, very important. As I told you before, your table of values carries the highest mark. So, the first value was, let's draw another line like this. Follow me and replicate exactly what you see me doing in your book. Your table of values carries the highest mark. So, the first value we have here, we have recorded I0 and V0 on top. So the next thing is pj. We record pj here. pj / cm. You draw a line. Good. The next thing we have to include here is your I and V. I is current in ampere and V is potential difference in volts. So write I / ampere. You draw a straight line. And then the last one is V / volts. That's it. So we are going to draw a straight line. Now, if you observe, how many times are we going to run the experiment? Let's count. Your first value is pj equals to 40. This is count. This is 1. This is 1. This is 2. This is 3. This is 4. This is 5. It means that we are going to run the experiment 5 times. So this is 1. This is 2. This is 3. This is 4. This is 5. So you draw a straight line here. You draw another straight line here. Sometimes your table of values carry 10 marks, 9 marks, sometimes 11 marks. So follow me as I do this with you, and then you draw. Good. So this is how your table of values is going to look like. Table of values or observations. Do you see that? Good. So we are done with the table of values. The next thing we want to do right now is to connect the circuit diagram the way it is. But then let's quickly enter the values of PJ. The first value was 40 cm. So write 40.00. Don't write 40. Everything here, we are going to record them to 2 decimal places. So we have the next one is 50. 50.00. We have the next one is 60. 60.00. We have 70.00. We have 80.00. So this is what I mean. Good. So let's connect the circuit diagram the way it is supposed to be connected. Then we will start running the experiments. So this is the circuit diagram. We need, this is the battery brackets, the power of the circuit, the EMF. Let us place it here. Good. This is the plus side. The plus side will face this side. So without wasting more time, let's just do it. This is what I mean. Good. The plus here, the negative here. So we are done with the battery. That's the key. The key. Let's put the key here. The key. Let's place the key here. This is the key. Good. The next thing is the standard resistor. This is a standard resistor. Probably this is 2 ohm. Let's place it here. We need how many connection wires? Let's count. This is 1, 2, 3, 4, 5, 6, 7, 8. We need 8 connection wires. Let's count again. This is 1, 2, 3, 4, 5, 6, 7, 8. 8 connection wires. So let's count. This is 1, 2, 3, 4, 5, 6, 7, 8. Exactly what I told you. So the next thing we are going to do is to place, this is the ammeter. Before we connect the ammeter, quickly observe something. We are using the down calibration 0 to 3. That is 0 to 3. We're not using the up one. If you're using the up one, the calibration is 0.2 divided by 10. You get 0.02. So because we're using the down one, it is 0.6 divided by 10. That is 0.06. So any value you get here, it is that value times 0.06. That's it. So we place it here. This is the voltmeter. The ammeter measures current in ampere. So the voltmeter measures current, put PD in volts. So the calibration is this: 1 divided by 10 will give you 0.1. So that is the value for each small line you see here. So any value you get, if it is standing somewhere here, that's 15. 15 times 0.1. Good. So let's place ammeter somewhere here. So this is the potentiometer. The potentiometer works with the equation R is equals to rho L all over A. I have explained that all in the video I asked you to watch in the description box. I hope we are good. So this is the potentiometer. We're going to place it here and then we'll do the connection. So this is the jockey. The jockey will be used, this particular guy here. This is the jockey. So this line P, this line PQ is simply the length of the potentiometer. The line PQ is simply the length of the potentiometer. So let's start our connection. So we have from the battery to the key, this is it. And then from the key to the potentiometer, from the key to the potentiometer, this is what we have. Let's use a short connection wire from the key to the potentiometer. Good. And then from the battery, from the battery to the standard resistor X. Yes. And then from the standard resistor to the ammeter. Good. And then from the ammeter, this section now, from the ammeter to one end of the potentiometer, let's use this. The ammeter to one end of the potentiometer, that's it. And then from the potentiometer, the voltmeter will be connected across the potentiometer. This is it here, across the potentiometer. So from the voltmeter, this is one end of the voltmeter, down to this leg of the ammeter. Good. And then the next connection is from this end to this other end. The next connection is the jockey. Take note, the jockey is also here. So there are 3 wires here, 1, 2, 3. 1, 2, 3. So this is the wire for the jockey. We connect it here. And then we do this here. Yes, our circuit is working. You can see that deflection clockwise, meaning our connection is correct. So you can see also the ammeter, the voltmeter reading clockwise. So now the jockey is not in contact. We are done with the circuit diagram. So, and also the connection. The next thing is to run the experiment now. They ask us to make contact, to take the reading when the jockey was not in contact. So let's quickly do that. I told you each reading here is what? Do you remember? I told you that this guy, by using the down calibration, 0.6 by 10, that is 0.06. So each value there is 0.06 times that value. Here is 1 divided by 10, that is 0.1. So each value times 0.1 is what we are going to do. So let's get set for the experiment. Let's get set for the experiment. So this is our jockey, and this is that for that. So let's start. I have a sticky note here for us to do some little calculations. So I make the circuit. Good. Quick. I have 5. I have this is 10, 15, 16. I have 16. Good. What do I mean? I have 5 here, I have 16. So it means that what? 5. You see, I quickly remove the key. If I don't remove the key, the battery will be drained and I will not have a successful experiment. Do you get what I'm saying? Good. So each time you are done, you see what I did? I had a sticky note here. I said 5, I said 6. Meaning this 5 times 0.06. That is what I mean. And then the voltmeter is 16. It means 16 times 0.1. So I will record the values here to 2 decimal places. So let's do it quickly. So I have 5 I have 5 times 0.06. Good. So the peak current I naught when the jockey was not in contact is simply 0.25 ampere. That's it. So the peak voltage when the jockey was not in contact here was simply what? 16 times 0.1. So right, so 16 times 0.1. So we have 1.6 volts. So write 1.6 volts. 1.60 volts. This is exactly what the examiners will want you to do. And so they now ask us to place the jockey. You can go back to what we did the first time. I asked you to screenshot this. So they asked us to place the jockey at 40. Make the circuit and then find the reading. So let's do it quickly. Now you can't place the jockey first before you make the circuit. You have to make the circuit first before you place you tap in the jockey. So let's do it quickly. That's it. So at 40, this is where 40 is. Don't touch it with your hand. So my sticky note is here to take it quickly. So this is 40. Whoa. At 40, I have, this is a 1, 2, 3, 4, 5, 5.5. Or let's say 6. I have 6. 6 common. Here I have what? 10, 11, 12, 13.5. I have a 13.5. What do I mean? So I will quickly remove the key. Place this here. What do I mean? I have 6, I have 13.5. That is to say, I have 6 times 0.06. What do I have? I have 0.36. So the ammeter reading is actually 0.36. While my voltmeter reading is 13.5 times 0.1. So I have 1.35. 1.35. So the next value is 50. So we'll make the key again quickly. At 50. We'll place the key at 50. Good. At 50 I have 1, 2, 3, 4, 5, 6. At 50 I have 6. I have 10, 11, 12. I have 12 here. Okay, I have 6.5. 6.5. So I have 6.5. I have 6.5. 11, 12. I have 12. 6.5. I have 12. It means that here is 6.5. So 6.5 times 0.06. 6.5 times 0.06. I have the value here is 0.39. So we have 12 times 0.1. I have 1.2. But I will not record 1.2. I will record 1.20. So 1.20 is what I will record. So the next thing I will do is to place it at 60. So I will make the circuit quickly. Make the circuit at 60. What do I have at 60? At 60, I have 7. I have 7. I have 11.5. 7, 11.5. 7, 11.5. 7, 11.5. So 7. So we'll say 7 times 0.06. Here I have 0.42. 7 times 0.06. I have that. So 11.5 times 0.1. That will give me 1.15. The next value, sorry, I didn't remove the key. That was an error. Sorry about that. So the next value is 70. Is 70. The jockey is at 70 right now. So at 70, I have 7.5 now. I have 7.5. Here I have 10.5. 10.5. So 7.5 times 0.06. That will give me 0.45. So 10.5 times 0.1. That will give me 1.05. The last value is 80. The jockey will be at 80 right now. So if the jockey is at 80, let's quickly make the circuits. Where's my key? Oh, okay, let me use this one. You make the key quickly. At 80, this is 80. The jockey at 80, I have 8. I have 8, I have 10. I have 8, I have 10 here. 8, 10. 8, 10. It means that 8 times 0.06, that will give me 0.48. That will give me 0.48. So 10 times 0.1, that will give me 1 point, just 1, right, 1.00. We are done with the experiment. Behold your table of values. A round of applause for me, please. So this is the table of values. So, and this is exactly what you are going to do in your external exams. Now, let's observe the table of values quickly. If you observe this table of values, you have a decrease. The value of the length is increasing down. You have increase. You have also increase. This column and this column have increase trend. Why this and this is increase, decrease. Increase, decrease. Increase, increase. Increase trend. Increase, decrease. So we are going to plot a graph of V on the vertical axis and this on the horizontal. That is a graph of I against V. You know from Ohm's law, we have V is equal to IR. From Ohm's law, we have V is equal to IR. Do you get? So the graph dividing both side by I, will give you V over I is equal to what? R. But in this case, they ask us to find what the graph of I on the vertical axis, and then so we are free to write that is I on the vertical axis and then V on vertical on the horizontal axis. Again, this is one equation controlling this experiment. The other one I want to show you is The resistance of a wire R is proportional to the length all over the area, and R is equals to rho L all over A. This is another equation controlling this experiment. These are the equations. So in the next video, we are going to use this table of values to plot the graph and answer all the remaining questions. Thank you for staying here with me. Don't forget to click in the description box to watch all the theory regarding this experiment, and also share this video, comment, and make a contribution. I love to improve. I love receiving constructive criticism. Thank you. God bless you. Bye bye.